Hi, I'm Pete. I work at Just Eat. I'm a senior engineer. I've been there since 2010 or so. If you've got any questions, then just raise your hand, shout them out, wave, because I'll probably not see you at the back, because that's a bit more fun, a bit more engaging. It's the end of the day, so let's do that. Who is a happy customer of Just Eat? Who doesn't know what Just Eat do? It's always one. Okay. We're an online takeaway. We do the sales channel for online for our restaurant partners. You come to the site, put some food in the basket, check out. We tell the restaurant about the food, about the order, about you. They ship you the food. That's it. We take a cut. Okay, so that was quick. We started in Denmark in 2001. We started in the UK in 2005. We're now in about 15 countries. One core platform with a couple of different versions depending on which country it's in. Few merged and acquired companies along the way with their own platforms that we keep ticking along. And as I said, I started in January 2010. I was, I think, tech employee number 5. It was a reboot of the technology team, so I wasn't there from the beginning. But we started again in the UK. And now we have, I don't know, about 250 people in the technology unit. So that includes product, UX, designers, operations specialists, QA specialists, writing code specialists, and we're all engineers together. We are a Windows platform, so WinOps. So all of the code that makes money is .NET, mostly C#. All of the code that doesn't, supports it, is, well, anything else, because why would you? We're hosted in AWS, and we do things at a reasonable scale. So yeah, this is a talk about performance. So let's baseline what we're talking about for the Just Eat context. For us, we need to serve around 70 searches a second at the head of the conversion funnel. So the conversion funnel is roughly, you tell us where you live, or tell us where you want your food. We give you a list of restaurants on the search results page. You pick one of them. We show you the menu. You decide, actually, no, go back and forth through the funnel, hopefully. You put some food in the basket, and you check out. And then we tell you about whether you're going to get your food or not. And usually we do, give you your food. So yeah, at the head of the funnel, 70 searches a second. At the conversion point, about 1,000 orders a minute. Some of those are online, some of those are cash, but about that. We have about 25,000 restaurant partners in the UK and more worldwide, but we're focused on the UK for this talk. And we have several million active users in the UK. By contrast, 6 years ago, when I joined, part of the day was spent figuring out why in Denmark, which was the biggest country at the time, we had fallen over at 2 to 3 orders a minute. The other half of the day was spent going to a pound shop to buy some space heaters because we didn't have any central heating. And figuring out why we had fallen over on the busiest day at the time of year for the 3rd year running. So, it was a bit, we hadn't quite got this operational thing back then. We've got better. But that frames the context. Who can tell me when peak time is? If you're in my demo, you already know. Sorry? 5 till 9, yeah. So basically, I'm hungry. Hey, do you fancy a takeaway, curry? Yeah, let's do that. That's pretty much what happens. You finish your day at work, you're hungry, you order some food. That's what we want you all to do. Please do that. And that tails off about 8 o'clock, 9 o'clock, something like that, because you've eaten, so you're not hungry anymore. So, we're worthless to you. So, it's also the same time that we DoS ourselves, every day. Sorry, the chart isn't so great. The blue line, which starts around here at around 4, curls up and stays pretty static, then turns off again. That's test orders. The green line is our real traffic profile. There are no numbers on the left. Sorry, we're a public company. I can't tell you those. And then the red line, which is impossible to see, is the total orders that we're processing. That's a chart taken from the 14th of December, and it's about roughly 1,000, 1,200 real orders a minute, and we add another that again, sort of. We have a very predictable demand. It's very cyclic, predictable demand. So it's busiest in the evenings. It's busiest towards the end of the week, so Friday and Saturday. We have a monthly cyclic of, it's a payday weekend, so people pay for takeaway to celebrate, I guess. And then we have a seasonal demand variation as well, so when it's wet, when it's cold and miserable, people buy takeaway. Our busiest day of the year, or at least it was about a year ago, was Valentine's Day, when it was on a Saturday. Kills me. In the UK, anyway. I'm sure in other countries, people are more romantic. But yeah, we love the rain because people buy takeout in the rain. And we do continuous delivery, and this is a massive problem. Because, well, again, to frame it, in 2010, we did maybe 30 deployments because, quite frankly, we didn't know what the hell we were doing, and we didn't know where production was, and we didn't know which servers were there, and we didn't have access to them, and we didn't know who did. We didn't know which workstation was the blessed one that the developer had last built on, and we certainly didn't know where that was. So, you know, there was a bit of a voyage of discovery in the early days. That's gone up on a curve. In 2014, we did more than 800 by October, and then we really stopped counting because we're doing this now, you know, tick. But yeah, the problem with continuous delivery is everyone wants to change everything all the time. So that means that regressions can creep in because, you know, we're human. We write tests, but we are human. And performance tests are, well, a bit dull, really. Who's run them and thought that? Come on. So yeah, the traditional approach. We did this for a while. I would say in 2012, this was how we did performance testing at Just Eat. In 2011, 2012, once we realized that we should probably start doing something. You have an environment, and it's a bit like production, except it's not, because it doesn't have the same numbers of servers in it. It doesn't have a load balancer, because those are expensive. This is pre-cloud. It doesn't have exactly the same configuration of servers. You run different applications on different things, and it's kind of sort of like production. It's at least a test environment, right? But, you know, nobody owns it, so it's always out of date. And everyone wants it, because you have to go through it to deploy, so it's never available. Duplicating production costs too much, so it's not the same. I mentioned, you know, talked about that. And of course, cost is an issue. The environment isn't in use all the time, but the hardware's bought. So you've got a pile of really kind of performant hardware that's sat there doing nothing for most of its lifetime. And if you make it do something, it's suddenly not appropriate to do performance testing on it because it's no longer clean. Who's, in a world of manual deployments, deployed something to a QA environment and not undone it when it didn't work? I don't believe you. Let the record show. Yeah, we did that, because this was before the days when we had deployment automation. And of course, individual tests take too long. So probably you're going to be talking about soaking the system for about an hour. There's stress tests, so you know they're stressful to the machine under test, the system under test. They're boring to watch, and they're boring to run, and they're boring to look at whether they were good or not. And so we didn't have automation for that. So boring things don't get learned and passed down. And then the context switch of failure is really expensive. Who here has run a performance test for 60 minutes and kicked it off and, oh, it's going well, I'll go and talk to that guy over there, or that person over there, or make a coffee, or anything like that, and come back after 60 minutes, because, you know, the test's going to take that long, and found out that it actually stopped running after 5 minutes. Yeah? Yeah, we did that too. But of course, you can't slow down delivery. You have to keep shipping things. You don't want to block people from releasing, so, you know, but you don't want to break it, because that's embarrassing, right? We're all professionals here. And performance regressions, oh, the home page takes 10 seconds to load. Oh, oops. So we test all the time as a defense against the chaos of continuous delivery. we continuously run some load through the system for the scenarios that we deeply care about, which is, for us, it's the bit that the customer gives us the money and the way onto that to allow them to give us the money and search for restaurants. And, for you, it'll be the bit that makes the money, whatever it is. And in production, we leverage monitoring and alerting systems deeply to make sure that we get no worse, or try to make sure that we get no worse. Remember, we're human. And of course, those functional tests, those are good too, but they don't really totally solve works in my environment, the equivalent of works on my machine as a developer, because often your environment just isn't production. The data is different, or it hasn't been torn down and rebuilt lately, or it hasn't had hygiene applied to it. For whatever reason, it's just different. So there's at least one person in this room wearing a T-shirt that leads me to think that he knows what slide is coming next. But can anyone else say what's coming next? Where do we test? Where is the... Yeah, you're wearing the T-shirt. So test in production. So this was a bit of a radical concept when we started talking about it 3 and a bit years ago. I remember quotes like this bandied around the office. I won't read them because, well, you can. I swear I heard this and this. So yeah, it turns out that customers are really good load agents because they come to your service and they buy stuff and they break things. And if you're lucky, they'll buy stuff and then they'll break things, but sometimes it's the other way around. And of course, you can't tell them to not break things because they won't come back. And customers generate far more chaos than our load agents do, because our load agents are just running a reasonably simple, crude scenario of, can I search for some restaurants? Can I put some food, pick one, put some food in the basket, check out? There's some variation there, but not that much. So, reasons why this isn't insane. Yeah, we have quite tight feedback loops at Just Eat. We have engineers that are deeply embedded in supporting what they ship. So I can write some code on my workstation, forget to compile it, push it, CI will tell me I did a terrible job. Or I can write some code on my workstation, and it sails through QA, and it has a performance bug in it because I didn't take out the thread.sleeps. And alerting will tell me because the response time now is higher. So, but the key thing is, it won't just be some red thing on a dashboard. It will be an obnoxious noise in my personal time, or my colleague's personal time who's on call with me, and there's camaraderie there, saying that, well, this wasn't quite good enough, so roll back. And of course, we have the ability to roll back because we've got a clue around automation and wrote some deployment automation that allows you to roll back, and tested it after a while of not having tested it. We are human. And we have teams that are cross-functions. So we have teams that are small, and they have specialisms present within the team. So there are QA engineers and there are engineers, whatever the developer, and we have people that are a specialist in operating in production, but everyone does all of the things around shipping code. There is no tester writes tests. Everyone writes tests, just the QA is going to be better at it. We have engineers that are empowered to own their code and empowered to own the products and services that they're shipping, so they can make their own decisions within constraints around what they're working on and why, and how they do it. How is a given. An engineer will decide, or a team of engineers will decide how to ship something. They might not totally decide what they're working on at any given point. The product roadmap, the technology roadmap, the business as usual roadmap all play a part in what we work on. But if you have a bad time in production when you're on call, then you're going to probably fix what gave you a bad time in production if you're able. You're going to do root cause analysis, and nobody's going to question that because it's a surprise. Context switching is expensive. We also have some decent tools around knowing what went bump. We have a platform with near real-time monitoring and alerting. We use open source tools for this, StatsD, Graphite, Grafana, Seiren, that stuff. We have centralized logs, so we can find out what went wrong, as opposed to something is wrong. So centralized logs, we use the elk stack. As I mentioned, engineers get paged, really obnoxiously, the sad trombone, I hate it. And engineers can turn off fake load really easily. That's kind of important, because what we've done here is we've injected synthetic load, but we've also given ourselves the release valve. So if at any point there's a spike, or there's a performance-related problem, we can turn off fake load, and immediately the system breathes a sigh of relief and recovers a bit, while we buy ourselves time to think if there is a natural spike in demand for our capacity. And as I mentioned, engineers can roll back quickly and easily. So how do we start doing this? I guess there's technology aspects to this. You have to learn how to actually pump load through a system in a reasonably efficient way. And there's people aspects to this. You have to basically reassure your managers that this isn't insane. So I guess first of all, you have to have the idea. And just to be clear, this wasn't our idea. There's prior art here. This is a link to one such blog post from, I think, an engineer at Dropbox who talks about it at length. And I think we basically read that and went, that's fantastic. And it's been a journey of bleeding on it ever since. But yeah, you have to choose the scenarios that you care about. You can't just add fake load to everything and expect that to be a really good time. You have to prioritize, just like with any other software that you create. So for us, that's customer has to be able to buy food. That's really the whole ball game. Who in the room has functional test coverage for this sort of scenario for your own system? Oh, come on, really? Up high. You know, you're writing behavior-driven tests, you have unit tests, you have test coverage around your core money-making bit of the system. So I would say that's about 20% of the people in the room. So a good way to get started is to reuse that, because it's testing your core thing. Maybe you have to change the data a bit, but you can run that in a loop. That's a decent way to start. You can tell it that, you know, production has this data, so hard code some data to get started. That gets you some load without needing to learn any new tools, because you already have those tests written. Choose a load agent. We chose JMeter. It's free. It's got reasonable UI for recording scenarios, and it's friendly towards automating, as in it has a command line that you can run, and it has decent reporting, and provisioning onto machines is now not so much of a thing in the Windows world with Chocolatey and OneGet. But that's an arbitrary choice on our part. There are other alternatives, both commercial and free. There's Gatling, there's Tsung, there's Grinder. One of those lets you write your load tests in Erlang. If that's interesting, it's a decent way to try out Erlang, if you're interested. And yeah, various commercial ones, which I don't know about because we use JMeter. You have to gain confidence when your system is quiet, because trying this for the first time at peak time is probably a little bit risky. And let's be clear, right? We're testing in production, and if we get stuff wrong, there will be repercussions. So while you're in this sort of softly, catchy monkey phase of things, this is the part where you're reassuring stakeholders that it's going to be fine. This is a good idea. We are going to learn from this. We are going to have problems, but we are going to gently tickle the system around the edges and then gain confidence and scale up over time. So you'll probably find that, you know, you're missing some alerts. Yes, question at the back.
Do you do all of this against all of production? You don't do any segregation for CD or your testing against everything in production?
So the question is, do we do this against all of the things in production? Well, for us, production is big. It's made out of about 120 different things, different discrete things. So, for example, the SQL Server, the consumer API, the public API, different websites for different functions. I will not say the microservices word. Different workers for event processing, because we've realized that queuing in the database is a terrible idea at scale, or certainly the transactional database. And so the scenarios that are core order do not touch all of those 120 things. They just touch the hot path of those 120 things. We haven't really defined it objectively, but there are certain parts of our system that are service critical, and then there's everything else. So no, I guess is the answer. You prioritize. And there's nothing stopping a team that owns a non-critical component from not running fake load against it. You can do that. But why would you? Because that's not critical. And there's critical bits that are not covered by fake load. It's prioritizing your effort. Did that answer the question? Yeah. Okay. So yeah, you start early in the day, everyone's in the office. That's first test. And there was a little cry of pain when someone started it and not everyone was ready for it. Graduate to later in the day. For us, remember our peak time's 5 p.m. Graduate to later in the day when real traffic is there. So for us, lunchtime. Not many people order takeaway at lunchtime because, well, I don't know really. And then you figure out that you're probably missing some alert coverage around resource metrics like CPU on particular servers or features of your platform. And so you fill those gaps and rerun. And so this is an iterative, familiar process. You know, you gain confidence and you do a bit more. You gain confidence, do a bit more. And just on defining alerts, it's better in general to measure what customers do, what people do, rather than what work computers do. Because if you know that at 5 p.m. you're expecting around 100 logins per minute, then when there's 80 logins per minute or 120, you know that's weird. And then you can drill into why. But if you know that the CPU is warm at 5 o'clock and it's warmer than normal, well, who's to know what's going on? So you really want to measure the customer actions on the website or the service rather than the resources of the service. So, okay, we've got our regular functional tests running in a loop. So now let's add some variety because, you know, for performance reasons, we do things like cache data. And so for hard-coded data for our functional tests, maybe we only retrieve the data from the data source the initial time that the fake load starts, and then it's in cache the entire time. So that's not a particularly realistic test. So let's expand, you know, rather than just have one user trying to order food, we now have several tens of thousands. So we hit different parts of the system to retrieve data and eject stuff from cache, and it's a bit more realistic. Similarly, when we started, we only had fake load for cache checkout because online payment providers, it turns out, don't really want you to load test them before you sign up to them, and certainly don't want you to load test them every night because, well, I don't know really. They don't want us to. Perhaps a bit telling about who we partner with. But then, yeah, later, we add some fake load restaurants. So there are some postcodes on our production site. I will not mention which they are because you can't buy food from them. Why would I? That are fake. There are things like Pavel's Test Kebab restaurant, and really there's a naming competition going on. So, you know, you expand the data that you test over for more realism. And then you make the computer do it every day. This is key. If you don't run the test every day, if you don't get the computer to do it every day, it's just like any other test that you don't run. It's worthless. So do that. This is the most vital part. The number of scenarios now doesn't fit on that screenshot. We have sort of Monday to Wednesday is lower thresholds, and Thursday through Sunday is higher thresholds. So this is just the top half of the fold. But yeah, you're basically keeping yourself honest. Green is good, red is bad. If it goes red, fix it, and then start the tests running again. Don't ignore them. Who ignores tests in the room? Yeah, it's okay, I do too. You can get more elaborate. So the online payment. Our business model works best if people are paying online rather than with cash. If people pay with cash, we have to go to the restaurants to say, please give us our cut. If people pay online, we have the money and we give the restaurants what they're due. So we don't have to do any debt collection. So that's better for us. So we want to encourage people to pay online. So we want to test that they can pay online, because sometimes they can't. So We do this by faking away those dependencies. We have a particular header, that's not it. Because for a while you could get free food if you knew the header. We have a particular header that identifies the type of the traffic. So this is, is fake. There's one that says this is real. There's one that says this is a test. Different scenarios, different header values. And so that allows us a seam of the platform to inject a piece of behavior in a really hopefully surgical way to the bit that is at the very boundary of our system that talks to the payment provider and makes it not talk to the payment provider but talk to a fake. So mocking at the architectural level, at the physical component level. We wrote a little test harness that has the same HTTP contract as our payment provider, and then it just says, yeah, we trust you. Yeah, you paid. And so now we have coverage for online orders. Not for our PSP, that's different, but all of our system is covered by load, the online checkout, I should say. And you can apply this in a number of different places. So for example, the bit that talks to restaurants to send them the actual orders, we haven't applied this to yet, but it's just some programming away. So we can expand the realism and the coverage just like you would when you're writing functional tests against a legacy platform or indeed against a new platform. You add tests around the bits that you care about the most, and then you iterate. You can get more elaborate. You can fake away the complicated things like the restaurants. So there's a magic box that prints out the order that sits in the restaurant, and it's connected to a GPRS network that sometimes works. And when we have a network outage, it really doesn't work. And so, we want to, again, expand the boundary of our testing to include the bit that communicates to the box, or indeed adjust the firmware of the box so it ignores the test order. That would be really good, because the restaurant doesn't want to participate in our tests. That is a safe assumption. So how have we kept doing this? And we learned a few things. As I said, don't allow the tests to be read, or at least not for very long. We get failures. When we have failures, we turn off fake load when we remember, because in the heat of failure in production, you sometimes forget the obvious things. We then fix the problem, and remember, this isn't on the hook in production when all the things are on fire. This is, we've now turned off fake load, so the problem has probably stopped. So the next day, we look at fixing the problem. If we re-enable the tests, it's important to not forget that step. And then, just like any other tests, when they go red again, you repeat. And you make things better as you go along. That's also something that we sometimes don't do, but we're not perfect. You need to tune the levels of load over time. So I guess going into Christmas last year, I don't think anyone had really looked at the level of fake load that we were running. And, well, we're a successful business, and so our customer load had gone up, and we hadn't really adjusted our fake load. So our headroom was getting smaller and smaller. Our confidence in our capacity was getting reduced. And so we adjusted it, because it's an int in Team City. And so we're done. No, we just discovered some other problems when we did that. So yeah, we don't want the safety net that capacity planning in an automated way gives us. We don't want the safety net to go away. So remember to tune the levels. We get smarter about managing data. We have an orders table, and apart from calling it order, which is a reserved word in SQL, which was a terrible idea, we made another bad decision about that in the mists of time, which is effectively unchangeable without rewriting that part, to basically, whenever someone makes an order, we write a row. And we've been doing that for 15 years now. We have quite a large orders table. So, we can do better about this. We can shard the data by date. We can shard the data by type of traffic. And we can stick a view in front of it for a relational database, or we can stick a read alias in front of it for Elasticsearch. There are options that are better than just one big fat thing. We still haven't written data archiving tools, but again, adding orders to this big table is a capacity test, and we can reclaim the capacity by deleting the orders reasonably easy. It would be easier if they're in a different table, but we can, we can just about figure our way around a where statement in a delete clause. Yeah. And you have to embrace the fact that things are going to break in really entertaining ways at the worst possible time. But that's software, you know. And at least here, you're in control of being able to turn off the load. So they'll stop breaking by hitting a button. So you really, what you're getting with the fake load is making them break faster, but then taking away the thing that makes them break. And then you've bought yourself that amount of time to fix when it would have happened naturally. That's really important. You buy yourself the leisure to prioritize differently, rather than, it's on fire right now, and I have to get everyone in the engineering team to drop what they're doing and work on this. Well, you don't, because actually that level of load is 3 months away, but you know it's coming. So yeah, this is a light-hearted scrabble through some of the things that went badly, which hopefully will be entertaining. We slipped up a bit in the run-up to Christmas 2015, and we had a large effort to make sure we were ready for that busy time of the year, because it snows. And we made lots of improvements, and we bled all over it. So it becomes important to know about bits of your platform that will return all of the data without bounding it by paging or without bounding it. At one point, we introduced the ability for a customer to see which orders they had made in the past. And then, well, great, okay, we shipped that. It's behind an API. It's in that SOA sense. It's a unit in its own right. It's on servers. It's new code. Great, brilliant, ship it, done, next. And then we enlisted it into fake load, because that's the right thing to do. And great, done that. We know how to use JMeter for this particular team now. Great, move on. 3 months later, this is running a bit slowly. Oh, now it's running quite a lot slowly. Why? I mean, we did a good job. It turns out that our scenario, when it asks for the order history, as you might imagine, for sort of 250,000 orders a night, when you add another 50% on top of that across tens of thousands, 10,000 or so fake load users, those users have quite a lot of orders. And so when you ask for an unbounded result set of the order history, that's quite a long list. Oh, that's why that's slow. Oops. So yeah, add paging. Stop fake load, add paging, turn on fake load, we're good. It turns out that the thing that you're using to monitor your platform has to be more available than your platform. So you probably need to scale your monitoring thing, whether it's a third-party thing or whether it's your thing that you're running, in advance of your platform. Otherwise, you're running blind. And so that's not good. So we did that. We did that a couple times. So Statsd, Graphite, Grafana, they have some quite reasonable ways to scale out and scale up. And so we read some blog posts, and we did that. And I think we do some number in the millions of unique metrics and higher millions of metrics per second. So we measure a lot. There's a great post on this from Etsy, coderscraft.com. Measure everything. We do that. If it moves, chart it. And if it's important, wrap an alert around it. Don't just have a chart. We realized that AWS has some limits on things to stop you spending all of your money. But when you need to scale up because you need to expect more demand for your thing, if you run into those limits and you then can't scale up, that would be bad. So because we scaled up ahead of Christmas, we didn't have a particular problem at Christmas, but still, be aware of the limits within which your hosting is making you operate. So this happened to us for particular instance sizes in AWS. We'd started using a new instance type, and they hadn't really noticed yet. It's a support ticket away, but when you need the capacity, 15-minute response time for enterprise support isn't really quick enough, and then you have to wait the further amount of time for them to actually change the int, and then the further amount of time for new instances to bootstrap. So, stop the fake load, raise the support ticket, wait for them to do it, start the fake load again. Oh, scale up. Same for Dynamo. But because we had to scale up in advance to cope with the expected load, because we were triggering the expected load, we didn't have the problem for reals, we only had it at test time. Still in production. So we run multi-AZ within a region. If Ireland ever sinks, we have a different alarm go off. And we discovered that we're not that great at configuring HA proxy, it turns out. It has a really good manual, but we should really get around to reading it. It was balancing all of the load to a single AZ rather than all three. Whoops. So yeah, we fixed that. That blew away the session state mechanism that we had in place, which was essentially one server in each AZ running the session state service. So it was sticky to AZ, but not instances within an AZ. So yeah, fix that, move along, next. This is the kicker, you can't really fix this easily. So yeah, this is on me really, so I can talk about it. Is that legible at the back? The joy of HTML slides. Okay, sorry. It's me basically saying, hey, that Apple Pay scenario for fake load that was creating a single new user every time it ran, every day, thousands of times a day, with the same email address, that one, did it change that so that the email address is different now every time it creates an email address? Within our system, for reasons, it is possible to sign up as a user with the same email address as an existing user. Good reasons, apparently. So we introduced Apple Pay in time for the launch event with Apple, and it's been happily ticking along in our system at this point for, I don't know, 3-4 months. Got 5 minutes, okay. And we had this fake load scenario because it's the right thing to do. And it was creating these users, and we didn't really care because there was no noticeable performance degradation on our alerts. And before you know it, 350,000 of these entries are in the users table, and that turns out to be about 5% of the users table. So coming into the busy season, SQL Server's under memory pressure. So failures in a distributed system, in a complicated system, are never just one thing's fault. It's always a combination of things that combine to screw you. But yeah, SQL Server's under memory pressure, and it turns out that when SQL Server wants some memory, it kicks out the compiled query cache plans and recompiles them. So when the login operation comes along, and it's a fake load user, and the query plan cache, it's really hard to say, the cache plan has been ejected, it recompiles the plan and goes, oh, well, 5% of the table is this user, so it's totally reasonable to do a table scan here. No, it's not, but you will. So yeah, and again, turn off fake load, problem goes away, fix the problem, kick yourself in the head, and then move along. And the irony here is, this is why I had to leave early last year. But the most important point really is that you discover all of these problems during peacetime, not wartime, and that's really key to having a good, well, time of software development. You can always turn off the thing that is killing you. So what did we gain? We have continuous peace of mind for capacity, for getting slower, for running out of capacity, and we want to aim for get no worse without noticing. You can get worse, but if you notice, then it becomes a data-driven conversation with the person pushing features to say, well, this is slower now, and that's causing this to conversion. Do that sort of hit and miss, but so it becomes a conversation that's a lot slower, a lot faster, because you have some data to go in to say, well, it's this much slower, it's this much worse. Our budget for this operation is this many milliseconds or this many seconds, whatever. We also know that we're good on if we're good on a Thursday night, if no alarms go off, we can be pretty certain that we're going to be good on Saturday night, because we run Saturday on Thursday, so we know in advance. And we maintain acceptable headroom for a projected 6 months of growth, and we tune our levels now, because we remembered that that's a key thing. And we also remember we're in the cloud, and it's great, but it's not our cloud, so that can trip you up. Number 2 is we have a really good, simple, clear operational response for when anything pretty much goes wrong. If fake load is running, stop it, scale up, and now start to think. And you can imagine you're in the pub on call, because you go to the pub when you're on call, right? You drink with your fellow on-call engineers, right? So you're in the pub. Maybe you've had one or two. And yeah, the PagerDuty sad trombone is going off. I hate that thing. And you don't have to start thinking about it until some stuff has already been actioned that will probably get you out of whatever the performance trouble is. If it's a third party, you're still screwed, but at least it's not performance. Number 3, if we've got a problem on Thursday night, we've got a really simple process. We turn off fake load for the weekend. So we're probably fine for the weekend, and so we'll fix it on Monday, because we kind of like having personal time as engineers. And as a company, we recognize that if engineers burn out, they leave, and then we have 2 problems. So yeah, we're respectful to the personal time of our engineers. We treat performance and operability as a first-class concern at Just Eat. No engineer, no anyone really, wants their personal time interrupted. And we know that, and we've learned that, ready for production is not the same as ready for customers necessarily. So we test stuff dark before customers see it, but in production. And of course, this also stimulates performance profiling happening over on the workstation or during CI, or maybe there's some automated performance test now in CI, because someone's realized that TeamCity has a .trace plugin, and it can do things like time the execution of tests and fail if it gets worse. We have the notion that alerts are just a different type of automated test that run in production, and they run regularly, like every 30 seconds or more often, however, as often as they can. And they're alerting on the data in monitoring. They're not actively touching the environment to see what the response time is. We're measuring the response time and publishing to monitoring, and then the alert looks at monitoring. So we have a single source of truth. We're promoting the idea of performance budgets for particular operations, the service criticality thing as well. And as I mentioned, this makes the conversation about, well, we need to do some engineering optimization stuff to things. That conversation goes a lot easier. We have Git push production being one step closer. We do continuous delivery, but there's still always something you can do to reduce the feedback loop, the time the feedback loop takes. And continuous testing can be done for more than just performance. That header that I mentioned, that's a really good seam to, return a pre-canned response. So you now can isolate your data from your environment and run those tests in every environment. And run those tests, I have 2 environments for my team, for my stuff, but I only run my stuff there. Another team might want to run my stuff, but get confidence that it works. That's a thing. So this lets that happen without needing to spend time with database migrations and data and managing data, because that's a pain. So yeah, we've gained a lot of stuff. It also means onboarding people is faster, because with that level of testing, your first checkout experience can be check it out, generate the configuration for tests, and go to the health check page. Here's a list of things you now have to do, first checkout person. So it's a series of steps you have to do to get running. So yeah, that's the end of the presentation. There's quite a lot more that goes into the pizza than you might think, and we're hiring, because everyone's hiring, right? So if you're interested, tap me up in the social bit, and that's me. Any questions just while people file in? Yes. We use StatsD, Graphite, Grafana for the collection and aggregation and visualization of data. And then we use a thing called Sarin, which is the thing that we define checks in, and that looks at Graphite to evaluate whether a check is good or bad. Yes? Yes? So the question was, we're using this for the e-commerce platform. Has the internal infrastructure team adopted aspects of this for what they do? Not to the same degree, but bits, yes. Steve, have I got time for more questions while people fall in?
Yeah. So
yeah?
Come on in, guys.
Yeah.
If he wants to answer your questions, that's fine. But just keep coming in. If you're sat on the end of the row, blocking a row, please be your ass and so on. a DevOps way. Finding constraint, fix it.
Yes.
You say you have to taking orders, but you knock out your payments. Is it the payments part of your
So yes, absolutely. So the question is, I say we mock out bits of the platform when we're running through the customer can pay, and so, but we're mocking away the payment provider. So yes, it's not totally realistic. But on the other hand, if it were realistic, we'd be making real traffic to our payment provider. They'd be charging us for that, and it would be 50% above our, the rate at which we do that is another 50% on top. And we wouldn't really be gaining anything because that payment emulator, we can just put a sleep in there to wait the same time the payment service provider would. So it's an acceptable deviation from realism. Or it's a known deviation, and it's okay.
Has the payment provider ever failed?
Yes, but happily we have a spare.
Have you ever worked with WorldPay?
We don't use them. All right, thank you, everyone.
So thanks very much, Pete.